the UTRGV College of Science High School Research Scholars Program, known as the High Scholars Program, successfully completed its launch in the summer of 2016. The High Scholars mission is to give Valley High School students the opportunity to experience a university environment where they can conduct research and learn the principles of scientific study.
The main purpose is to create new knowledge. This is not a program in which students will just learn techniques and the program is over. It is students will actually act as scientists. They will be under the guidance of their mentors and co-mentors, what they will end up, hopefully, even publishing some papers, original research papers.
This 9-week research program targeted high school students with excellent academic performance from high schools across the Rio Grande Valley. The High Scholars Program seeks to enhance critical thinking skills in STEM-related fields. 48 faculty in the departments of biology, chemistry, physics, astronomy, mathematics, environmental science, and engineering mentored 106 participating students.
I am looking at manufacturing engineering as my career in the future. Right now I'm making a solenoid maker, which generally the solenoids that they were making previously would have to be hand wound, but the maker that I'm designing would do it automatically.
The students work 25 hours a week in laboratories across the university's Brownsville and Edinburgh campuses to conduct original scientific research with their faculty mentors and university graduate students.
I wanted to go more than just wound dressing for patients, then actually make it better, their healing experience more efficient by actually having an indicator that changes colors when bacteria such as E. coli get in there. So right now we apply something called EMB agar, which is eosine methylene blue agar, and that polymer we spin it into our nanofibers, and right now we're checking in the microscope if it changes colors.
We're trying to do combine nanofibers and macrofibers to be able to mimic a beetle, which is in the Namib desert. It's an Namib beetle, which has the characteristic of recollecting water from the air in the desert. I was measuring the mats, the nanofiber with the macrofiber on top, and we glue it, and then we hang it, and we put it in an accelerated environment, which is with a vaporizer that increases the humidity, so we can kind of approximate how much water would it recollect in an environment like here.
So they are working two different molecules each, so they have the target molecule, two of them has different, and they are trying to make a different compound. So we will try the molecule they made to test if it has bioactivity or not.
We are working to see if this certain chemical called quinoline 5-A-dione is bioactive with cancer cells, specifically breast cancer cells. So hopefully, the final goal is in reality to see if this could help people. This is a column, and this is a sort of further purification process. And we pack this with silica gel and our lumen, and then we let it drain, and we put our product and a layer of sand on top. And basically our product is being filtered through the layers of silica gel and it's coming out.
I'm working with pyrazine-fused endoquinones. From what Dr. Mitos described to me, it deactivates the molecule, so it no longer be effective. So basically, the research that I'm contributing to is seeing if a procedure that worked for the benzene-fused endoquinones will also work for the pyrazine-fused endoquinones.
In addition to the hands-on lab experience, students attended weekly lunch and learn sessions where they were exposed to the philosophy of science, ethics, scientific method, critical thinking, technical writing, scientific presentation, experimental design, data analysis, and professional development skills, including leadership and teamwork.
I love working with the high school students. So I think Dr. Gruel and all the faculty, 50+ faculty that are involved in the program, they're doing a great job. And that's what I've been trying to do all of these years. I deeply enjoy, when I present to the kids.
At the end of the 9 weeks, students presented their research findings with a poster presentation and submitted a 3-page summary describing their research method, results obtained, a brief discussion of their work, and their experiences in the program.
Okay, so and we had another microfiber in the
Basically, what they're trying to do is transform the train's lateral motion into energy to power onboard sensors. The methodology behind it was we came up with the idea, the initial sketch. We took that sketch, made it into a SolidWorks file, and then once we kind of modified that, we came here and started machining these walls with the mill. It's obviously a learning process. I've never used these machines. It's been a really good experience. I've been learning a lot. Everyone here is very welcoming and understanding, guiding me through the steps that I need to take to be a better engineer.
I think the High Scholars program is a great way to have younger people like me come and do research in actual labs.
I think working in this lab, I've learned just like a lot of relevant lab experience. I guess just, like the reality of a lab versus my preconception of what a lab is.
I'm just really happy to be here, and I feel I didn't know ahead of time exactly what I was going to be put with, but I'm really happy that I'm doing something related to cancer, because specifically breast cancer, because my aunt actually had breast cancer and she survived it luckily. But it's cool to think that maybe this could be something that could help other people who are suffering from breast cancer. So I think it's an awesome benefit.
I would have never expected that there were programs like this in the Valley for high school students. So it's pretty cool, and I've learned a lot of stuff. I'm more excited to become an engineer or a scientist.